Okay, so this is consumer theory number 3. We are at lecture 3. So today we will study perfect substitutes, kinked preferences, and concave preferences. These are the utility functions. And in last class we studied Cobb-Douglas and perfect complement utility function. If you haven't watched it, do cover that video as well. Today let's start with perfect substitutes. So first of all, let's talk about an example. Like for example, now you are all in college, so like you must be carrying your pouch, as they say, in which you keep some of your stationery, like you keep blue pen, or you might be keeping any black pen also. Now in blue pen you must be keeping any some ball pens also, some gel pens also. But consider a day when you are in too much hurry for your internal examination and you forgot to bring your pouch, and then you asking your friends for help for an extra pen. Now, as a customary approach, they are asking you, do you need a ball pen or do you need a gel pen? Now, it does not matter for you that you use a ball blue pen or a blue gel pen to write your examination. So, uh, the two goods, the ball pen and the gel pen, these do not matter to you as long as the pen is blue. Okay, so this is the basic idea about the perfect substitutes, that a consumer is not preferring any one good out of the two goods available to him, unless of course there is a much of a quality difference or that, but that is not really relevant to our uh, syllabus right now. So this is what is all about perfect substitutes. Like a consumer is able to substitute one good for the other at a very similar and a constant rate. Like we are getting into the deeper sections about this. So let's write the general form first. U of x comma y equals ax plus by. Now if we calculate the MRS, which equals negative of mux by muy, we use partial derivatives and you would be getting negative of a by b. Now this a by b can are any constants, like we can have, for example, q equals 2x plus 5y, 3x plus 4y, 6x plus 9y, or endless utility functions like that. So these a by b are basically these coefficients: 2 by 5, 3 by 4, 6 by 9. You must be understanding that. Okay. Uh, Now there's a formal definition of it, like two goods, you may like to write it, are said to be perfect substitutes if a consumer is willing to sacrifice one for the other. Just 1 second. One good. 1 second. Okay, so the formal definition says this: two goods are said to be perfect substitutes if a consumer is willing to sacrifice one good for the other at a constant rate. Now, a common misconception about this perfect substitutes is that the MRS need not be 1 in every case. It must be just a constant. any constant value. Okay. All right. So now let's move to the optimal choice problem for perfect substitutes. Optimal choice for a consumer in two good space x and y. Okay. Now there in perfect substitutes, this is a kind of a different utility function where we have three cases. Okay, so let's write down case one where our MRS is greater than the price ratio. Okay, now let's understand this thing graphically first. Okay, I've drawn a good space where we have good y, good x, and the origin. Okay, now let's draw our perfect substitutes utility function. It's the red line. Okay, this is our IC, and our green line is the budget line. Now we are taking the case where MR is greater than P1 by P2, so the IC would be steeper than the budget line. The budget line slope is P1 by P2 in absolute terms, so our budget line would be this, flatter than the IC. Let's write budget line here. Okay, now since our IC is steeper than the budget line, then we need to look what is the highest IC we can reach for a consumer where he is spending all of his income and of course deriving the highest utility possible. Okay, so let's start moving our IC a bit. Is this the highest IC? No, he can even do better. So let's move it here sometimes. Is this the highest IC? No, he can do even better. Is this the highest IC? Let's check at this point. Let's extend it. Okay, so now this point, beyond this point, the bundles are not affordable as the green line is the budget line. So this is the equilibrium bundle when MRS is greater than P1 by P2. Or the consumer is deriving a maximum utility from good X as compared to good Y. Okay, so our bundles, demand bundles would be X star equals M by P1 and Y star equals 0. Let's move to case 2. Now our MRS is less than price ratio. Okay, let's draw the similar diagram, but this time the slopes would be different, of course. Now this is our IC, the perfect substitute linear IC, downward sloping IC. Okay, and since our budget line is steeper this time, our budget line would be steeper. So let's say our budget line is this blue one. This is the budget line. And this is the IC. Okay, now what's the highest indifference curve you can reach at this budget line? Let's try to move in this direction. Is this the highest indifference curve? No, we can do even better. Is this the highest? Let's check. Okay, so this is the highest IC we can derive, the consumer can reach, given that the budget line is steeper than the IC or price ratio is greater than the MRS. Here our demand bundles would be X star would be 0 and Y star would equals all of his income spent on good Y, so M by P2. Okay, so this one is the budget. This one is the equilibrium bundle. Let's move to case 3. Now this is the interesting case. Okay, where MRS equals the price ratio. Now let's draw our graphs again. Now in this case, the MRS, the IC and the budget line both have same slopes, no difference at all. So they would both the curves would be coincident on each other. Okay, so we are having infinite equilibrium combinations of the goods the consumer can derive. Good X here, good Y here. Now we can derive highest utility at all of these points, all equilibrium bundles. So let's write it in mathematical terms. So extra would be we can consume either 0 to all of x. That would be m by p1, and y star would be the income left after the income left after consuming good x divided by p2 star to p1 upon p2. Okay, so whenever we write in a manner that x star for one good we are writing the exact range, and for the second good we are writing the residual income after consuming good one divided by the price of that particular good. Okay, so that was all about our substitutes utility function. Okay, so just remember this case by the name infinite combinations. Infinite combinations. Right. Now let's move forward with the next kind of utility function. That would be the kinked preferences, or in another name, Allen substitutes utility function. Kinked preferences. Okay, so these kind of preferences we can only learn through a numerical example. So let's write. Okay, let utility function, the function of good x and good y, be minimum of 2x comma y, 2x plus y, sorry, and x plus 2y. Now don't be scared enough. This is a little tricky one, but as you go along your micro in semester 3, you would be uh, using this function many a times. Okay, so let's begin how to operate under this kind of function and in difference curve analysis. So to graph this first, okay, let's begin to graph this. Now we drop two good space. Okay, we have good y here, good x here. Okay, now the very first thing we need to do is to draw the kinked line. We have the kink where ax equals by. From the perfect complements case, you must be remembering we would be having 2x plus y equals x plus 2y, and this implies x equals y. Okay, so let's draw the x equals y line. Let's draw it cleanly. Okay, now we have drawn the kink line, which is x equals to y. Okay, now move to the second step. The second step would be to take cases. Now we take cases about the utility function. Now first we have to assume any kind of utility, and we would be using that utility level to plot the indifference curve. Let's assume the utility equals to 10, since we are having multiples of 2 in the utility function. So in first case, let 2x plus y be greater than x plus 2y. Since we have minimum function, our utility would be equaling x plus 2y, and we're plotting it equal to 10. Equal to 10. Okay, so our points would come like this, that we have 10 comma 0 as the x-intercept and 0 comma 5 as the y-intercept. 0 comma 5 and 10 comma 0. Now about this graph, we need to remember one thing, that we are having x greater than y points in this space, in this portion of the graph, and x less than y in this portion of the graph. Now when we are taking the first case as 2x plus y greater than x plus 2y, we are basically referring to x greater than y. X greater than y. Okay, so we are having intercepts as 10 comma 0 and 0 comma 5. Now 0 comma 5 line would go from this direction. Okay, but we only have to take the points where x greater than y condition satisfied. So we will draw this utility only in this space. Let's draw this. Let's take it a bit more clean. Okay, so this one would be at this segment. Now take let us take the other case. Let 2x plus y is less than x plus 2y, or x is less than y. Now this condition must be satisfied where u equals 10 or 2x plus y equals 10. Now intercept should be 5 comma 0 on x axis and 0 comma 10 on y axis, but 5 comma 0 would lie in x greater than y. We need x less than y, so our intercept for that would be 0 comma 10. So somewhere here, these points are just indicative. Okay, so we are drawing this segment here. We are drawing dotted line just to indicate you that in the notes that we need to draw the particular segment in the space where it is satisfied for the condition x less than y or x greater than y respectively. Okay, so this black line is our IC. Let's highlight it. This is our IC for the kinked preferences. For the kinked preferences. Okay, now let us take different price ratios and analyze the different choices the consumer can make. Okay, so let's take some prices. Case 1 where price ratio uh, is 1. First of all, let's see what are the slopes of these segments. So let's see. So the slope of this segment is 2. We can write it here. Slope of this segment is 1 by 2. We can write it here. Okay, this would help us to analyze the conditions more easily. So let us take price P1 as 1 and 2 as 3. Okay, so our price ratio equals 1 by 3. Okay, so where would the budget line lie? It would lie somewhere here, since it is flatter than 1 by 2 also. Okay, so now looking at the budget line and looking at the IC, we need to reach the highest IC. So in fact we have made it, the highest IC would lie here only. The highest IC would lie here only. Since bundles beyond this are not affordable, our budget line or our income is, our budget set is only in this area. So this would be our equilibrium bundle, where x star equals m by p1 and y star equals m by p2. Okay, now let's take case 2 where p1 equals 3 and p2 equals 1. Price ratio equals to 3. Okay, now let's draw another diagram for this. Let me copy that. Okay, the slopes are 2 for this segment, half for this segment. Our price ratio is 3, so our budget line would be steeper than this green, than this segment also. So our budget line would be somewhat like this. Okay, Now the highest IC we can reach is this point only. Okay, because any IC before this, that would be suboptimal. We will not be consuming the desirable quantities, and this would be the only equilibrium bundle where x star equals 0 and y star equals m by p2. Okay, now let's take case 3. Let's take case 3. Okay, now let's take a price issue between 2 and half. Let's take a price issue between 2 and half. So let P1 equals 3 and P2 equals 2. Price ratio equals 1.5. Okay, let's copy the diagram again. Let's copy the diagram again. Okay, now since the budget line is steeper than this segment and flatter than this segment, so budget line would be something like this. You can see it is steeper than this segment but flatter than this segment. Now the highest IC you can reach is at this kinked point where x equals to y. Okay, you can reach any higher IC you can try to reach, but this is the highest IC. So here our x star would be equal to y star, and you will do some algebraic manipulation or algebraic solving, and you will get them to be m upon p1 plus p2. Okay, so we have seen so far 3 cases where the budget line steeper than both the segments, flatter than both the segments, and between the slopes of both the segments. Okay, now let's take case 4. We have 5 cases for simplicity. So let's let a P1 be equal to 1 and P2 be equal to 2. So our price ratio equals to half, which is coinciding with a lower segment of the IC. Okay, now let's copy the diagram again. Let's copy the diagram again. So we have our segments, slope 2, slope 1 by 2, and a budget line. And our budget line is something coinciding with 1 by 2. Is something like this. Okay, now the highest IC, you ask yourself, what is the highest IC a consumer can reach given this budget line, the blue highlighted one, which is coinciding with this green portion. Okay, so the equilibrium bundle would be ranging from this point to this point. Now what is this point? We calculated earlier, m upon p1 plus p2. So equilibrium bundles would be x star equals m upon p1 plus p2 to m upon p1, where the consumer is consuming only x, all of x precisely, and y star would be residual income after consuming x star p1 divided by p2 Okay, now similarly, I am leaving case 5 to you guys. You put down the comment section what would be the equilibrium bundles in case 5, where our price ratio p1 equals to 2 and p2 equals to 1. So price ratio equals to 2. This is as a homework to you guys. Write down in the comment section what would be the equilibrium bundles in this case. Okay, so this was an example of Allen substitutability function. Normally, what a trend is like, you won't be asked kind of a kinked or Allen substitutability function in your final examination, but you never know. It's kind of a tricky question, tricky case, so you may get it for a 5 marker or maybe more. I don't know. I don't have any strong idea about it, but for completion's sake, we have to do it to build a basic strong. Okay. Okay. Now what do? We take the next utility function, which would be our max utility function. Okay. Now let's take next utility function, that is max utility function. But before doing this max utility function, let's come back to the perfect substitutes case. Let's come back to the perfect substitutes case. There was something, a tiny bit of important detail we need to discuss about. Okay, so for sometimes in the question you will be getting to frame the utility function. Like for example, you will be getting a situation kind of a thing. Like there is a consumer XYZ, and he consumes. He considers two goods to be perfect substitutes for each other, and he considers two breads, for example, two twice of x as good as one of y. Okay, where the word as good as is used, you must be clever to know that it is talking about perfect substitutes. But what do we need to do is that while framing the unity function, we would be swapping the values. Like you would be writing, if the question is saying that the consumer considers 2 units of good x as good as 1 unit of good y, we need to swap the values while forming the utility function. We would be writing u equals x plus 2y. The same goes for perfect complements case also. Like if, for example, the question might say that the consumer prefers to consume 2 units of x with every unit of y. So we will be swapping the values, and our utility function would be minimum of x comma 2y. Okay, so this is the trick in framing the utility function. And any more doubts about this particular point, you can ask in the comment section. I will try to reply as many as I can. Okay, so let's move now to the max utility function. The max utility function. Okay, the general form here would be u equals, one second, u equals max of ax comma by. Pardon the handwriting part. Okay, all right. So let's take an example first. Okay, now here the consumer is preferring to consume the maximum of good x or good y, whichever is available. So these preferences are non-convex. These preferences are non-convex in nature, as the consumer is preferring extremes to averages. He's never, considering to consume averages like sum of good x or sum of good y. He is considering either to consume all of x or all of y. So a rough diagram would be like this. Okay. Now let's take an example to make it more clear. Let's take u equals max of 2x comma y. Let's take 2x comma y. Okay, but we need to plot it first. So the very first thing, as our process goes, we need to plot the kink line. Our kink line would be 2x equals to y. So let's draw this graph first. 2x equals to y line would be somewhat a steeper line, because x equal to y line is a 45-degree line, and 2x equal to y line would be steeper than that. Okay, now these points, as I already said, x greater than y, and these segment x less than y. Okay, now let the case be, let's assume any utility. Let's utility would be 10 as always. Now let 2x less than y. One second. Let 2x less than y. So our u equals y in this case. Okay, now our twice of x is less than y. This implies x should be already less than y. Okay. For example, you can understand that twice of x is less than y. So x should be also less than y. For example, let's take y to be 10 and x to be 2. 4 is less than 10. 2 is also less than 10. Okay. So this was one example you can use to plot utility equals y. So in this case, x is in y, we would be satisfying this inequality, and we would be plotting y equals to 10k, 10 line. So this is 10, y equals to 10 line in this segment. Now let's take 2x greater than y, where u equals 2x. Okay. Now twice of x greater than y, so x would also be greater than y. Okay. Now let's plot this on a diagram. Now in the condition where x greater than y is satisfied, we would rank 2x equals to 10, which comes down to x equals to 5. So this would be our utility function. This is a utility function. This is our utility function for clarity. Okay, now what we need to do in this kind of max function for the optimal choice, there is a different kind of process for this. So step one would be to draw the line joining the endpoints. Line joining the endpoints. Okay, let us draw the line joining the endpoints first of the IC. So this is the red segment. Let's make it cleaner. This uh, this is the red segment. Let's end it here only. This is the red segment. Now we need to calculate the slope, okay, of this red line. Slope of this very line. Okay, now slope m equals y2 minus y1 upon x2 minus x1. So that comes down to minus 10 upon 5, that is minus 2. We will be ignoring the minus sign for the calculation purposes. Okay, now we have to calculate the price ratio as given. Okay, now if the price ratio uh, is less than this slope of this budget line, would be getting 2 greater than the price ratio. In this case, our x star would be, or our budget line would be flatter than this red segment. X star would be m by p1. Consumer will consume all of x. Y star would be 0. In another case, 2 can be less than price ratio as the question gives us the values. In this case, x star would be 0. Consumer will be consuming only y. Y star equals m by p2. Okay, in another case, it can happen that, one second, in another case, it can happen that 2 equals price ratio. Now this 2 is not the MRS. This 2 is not the MRS. You must note 2 is not the MRS. In max function, we are not getting the MRS. We are calculating the slope of the line at the endpoints of the IC. So in this case, consumer either consumes only x m1 m by p1 comma 0, or only y 0 comma m by p2. Okay. Now for more detailed explanation of max function, you can check out the econ in 6 seconds playlist, where I have taken all these utility functions in a very quick manner for quick revision. Okay. So this was all about our today's lecture, in which we studied perfect substitutes and Allen substitutes and max utility function. Now in next class, we'll be looking at concave utility functions and the food stamp program. Okay, that is a very basic analysis and application of our budget line analysis up till now. You can refer to Varian or Nicholson and Snyder for your reference readings. And if you love the video, do tell me in the comments what more we can provide you. And for time constraints sake, we will be providing some selected topics of micro, and of course full notes we provided for MME, micro and macro. That's not an issue. Okay, so do subscribe to the channel and like the video if you had a proper understanding of the utility functions. Let's meet next time.